Okay, so this video is for new members and future members that will be using the Tuner Studio software that we use for our ECU to control our CBR 600RR engine. In this video, I'm basically just going to run through all the buttons, tell you what each one does, and basically explain how it applies to us, how it applies to our engine, what they do, how we use them, and the sort of particular things that we use that are different from a typical engine or a typical non-restricted engine. So here in File we have projects, and the tune and saving, and how that works is basically your project folder includes your tune, restore points in your tune in case you screw up, as well as gauge setups and other stuff like that. So the project folder contains all of that, and then the tune itself is like the current tune that you're on. So just keep that in mind. Those are separate. The project folder is located in the Dropbox, so it should sync across all computers that would access the tune. As a matter of fact, Tuner Studio has a way to update the tune if someone else changes the file on the fly, so it's very convenient. It'll never be lost, and it's always going to be on the cloud. In we have options, data log, and stuff like that. In communications, this is also very important. So communications settings is what you'll be using here. So this is how you connect to the actual ECU. We will connect to the ECU later near the end of this video, and I'll show you what that looks like and how to do all that. But this is where you'll change those communication settings. Tools, this is where you'll do things like calibrate the TPS, calibrate the map, calibrate battery voltage. I've never had to calibrate the map or battery voltage, but the TPS is something that you'll be calibrating quite often. Moving on to the sort of Tuner Studio toolbar. So these basic settings are basically just what they sound like, basic settings. I'll just start from the top and kind of work my way down. Engine and sequential settings. So sequential meaning sequential fuel injection. Engine is of course the engine. This calculated required fuel, this basically takes a displacement and injector size. Here in engine size I have set to 600, even though the race engine is 636. Injector size, the orange ones are 99 cc per minute. The number of injectors is 4. We don't have 8 like the normal a normal CBR would. And number of cylinders, 4-stroke. Injector staging, as in simultaneous or alternating, as in which ones you fire at which points in time. Squirts per engine cycle, 1. And alpha N means it's using the TPS exclusively. That's what we use. If we had a map sensor that was reliable with an intake, you could use other forms of this. We don't use a MAF, of course, and we don't have individual throttle bodies. Sequential fuel injection is exactly what it sounds like. You can use this to either do batch or sequential fuel injection. The firing order is 1, 2, 4, 3 on this engine. This depends on how the injectors are wired. So if your injectors are wired 1, 2, 3, 4, you will set this to 1, 2, 4, 3. If they are wired 1, 2, 4, 3, you would set this to 1, 2, 3, 4. So it all depends. I like having it done in software, but you could do it in hardware, in wiring as well. General settings, so barometric correction, basically whatever altitude you're at, the onboard map sensor can use that sensor to basically automatically shift the entire fuel table and fuel map according to the altitude where you're at. Sacramento, of course, is basically sea level. Even though we're in a valley, it's not actually any higher. And Michigan is also almost identical, so I really leave this off. It's not critical. But if we were racing in Denver, it would be important. Or if we were racing in Death Valley, where the pressure is higher, it would also be important. The map sensor is basically, you can change to an external map sensor. I've always used the internal map sensor. If you wanted to use speed density or any other kind of control like that for the intake and controlling fueling. General sensor settings, basically what tables you use for, if you use Fahrenheit, Celsius, stuff like that. Lag factors, I've never messed with any of this. Auto zero TPS, I didn't even know you could do that, so that's pretty cool. Apparently you can do that. Primary fuel load, once again, this is alpha N because we're using the TPS. Secondary fuel load, as in you can combine multiple fuels. This isn't relevant to us because we only use one fuel, but drag racers, they might use, 100 octane or 91 octane or 93, and then also use meth or E85 or E90 or anything like that. So they would use two different fuel tables, and they might have two different sets of injectors, and maybe they use different fuel load types for each one. Ignition load, this is identical. This isn't super relevant to us. I suppose if you really wanted to, you could have ignition and fuel on different types, different lookup types. This isn't super relevant to us either. What is stoichiometric for your fuel? Since we're using 100 octane, it's actually not 14.7 for 100 octane. I think it's like 14.3. So I could change this if I wanted to, but right now we're on the test engine and we're not using 100 octane. We're just using 91, so it's 14.7. And rev limiter, this is exactly what it sounds like. So the rev limiter is based on the coolant temperature so that you don't cold rev it accidentally. This has happened before with drivers where everybody just kind of forgets that the car isn't warmed up yet, or you didn't warm the car up enough and it's time to go. So the coolant rev limiter is basically to make sure that nobody accidentally makes a mistake. So once it's at temperature, which is 180, it will rev to its full 14,000. Something like soft limit zone hysteresis. Hysteresis in general is basically how much are you willing to let it bounce, basically, so you don't have it bouncing back and forth. You can Google hysteresis and kind of learn what that's for. Rev limit, coolant based. It's coolant based. I feel like that's the best way to do it. You can also retard the spark in order to get rid of that, but I just limit it, so I just stop right there. So it cuts spark. It doesn't actually retard the spark, it just completely cuts it. And you can also use fuel cut if you so wished, but this works just fine. Shift lights, we use the data logger for shift lights, so this isn't super relevant to us. But if we used a different data logger or we switched data loggers, then that could be used for that. Engine state. This is pretty important, not super critical, but basically engine state is the engine, this tuning software has the ability to identify different states in the engine. So whether you are, and you can see them here, whether you're cruising, which is basically constant TPS above a certain threshold, and also not changing your speed. So basically think of it like you're on the highway. You're not accelerating or decelerating. Slow accel, fast accel, slow decel, fast decel. Overrun, you guys should know what overrun means. Idle is idle, wide open throttle. Idle VE means you're idling and you're using a separate VE table. I'll get to that later. Idle advanced and idle off, seal idle off. I don't actually know what this means. Basically, you can change the parameters for different states so that you can control how it identifies each state, and you may have to mess with this if it's not going into the idle state or if it's not going into certain other states. Hopefully it should be set up properly. So yeah, obviously it uses RPM dot, which you guys should know is change in RPM. So how quickly or fast or slowly the RPM is rising or falling will, show things like overrun if it's falling quickly, fast acceleration if it's increasing quickly, wide open throttle if TPS is at 100 and accelerating quickly, etc. Tacho output, we do have the TAC goes straight from the ECU into the dash. This is not strictly necessary. Theoretically, you could do this straight from the data logger, and perhaps that will be done in the future, but this is where you would do that. You can scale it to make sure that it's right. You can do other stuff like that. Half pulse or full pulse, depending. Usually we use full pulse, and you'll see the tooltips right here will tell you sort of what to do. Fixed or variable, ours is fixed. Some older cars might have variable based on a number of factors. There's many different ways to make tachometers, and since this ECU is sort of designed for replacing something in an old car, this is how you would maybe use an old gauge cluster and still have a newer ECU. Fan control. This is also very important. So the fan control, obviously we trigger it based on our coolant temperature, and it will either set high or it'll either pull up or pull down, which means you should be able to Google what pull up or pull down means. I won't explain it here. What output pin is it on? When does it do it? Fan comes on to 200, and then it lowers it back down, and then once it gets to 180, it shuts off. Allow fan when engine off. This means key on, engine off. It should allow the fan to go. This basically prevents you from... It makes it so that you can keep the engine off, which means you're not producing more heat, however, still allow the fan and water pump to run. So basically this allows you to cool off the engine. TPS shut off enable. You could enable this if you wanted to. So basically when you're driving, the fan is off. That certainly is not a bad idea, because the fan does use a decent amount of current, which puts more stress on the alternator and would sap power. So you certainly could enable this if you wanted, as long as you make sure that you're staying under control. I won't go into torque converter because we don't have one. Alternator control, we don't use this, but theoretically on a normal car you could. Map sample settings, we don't really use this. MAF settings, we don't use a MAF. Air density table, we don't really use that. But if you wanted to, you could have coolant correction for like a normal car, which, like I said, we don't use. Real-time display, this is like, basically it shows you like data. It's kind of like a gauge cluster, except it shows it in a graph. Here we go. Feature list showing I/O pins. This is also a really important one. So basically, a lot of times you're probably going to forget which pins are set up to do which things. So this is just a list of every single pin and what it is connected to in terms of a variable in the ECU, etc. So we have all sorts of things. EGO port is connected to O2 in. That's pretty obvious. EGT channel is connected to the CAN lines. Yeah, lots of stuff like that. Traction control, enable lights if those were set up. All sorts of stuff like that. Basically, tacho output is set to tack out. All sorts of stuff like that. Fan control as well is set to stepper out. You saw that in one of the previous menus. So this is like where you would see, you would remind yourself where those pins are basically used. This will show you which ones are being used. We're not online right now, so it doesn't work. But it's also very important. Gauge and gauge limits. This is basically going to set your gauges. I don't use this. I use the actual base gauge modifier, which we'll get to later. So fuel settings, injector dead time, and PWM, which is pulse width modulation. Basically, an injector is a solenoid, so you're opening it for a certain amount of time. Injector dead time is not something I ever recommend messing with unless you really know what you're doing. I mean, this is something that would be a professional would mess with, and we would not. Theoretically, if your injectors are perfect and flowing perfectly, you don't need to ever touch this. So, injector small pulse widths. This is also something that I would not recommend messing with. Basically, small pulse widths can cause issues with solenoid bounce in an injector and stuff like that. So maybe you would want to change it so that you don't have issues with that. I would never mess with this unless you are an actual professional. Stage injection. We don't have two sets of injectors, but we could, just like a normal CBR. And you can set up stage injection. This is significantly harder to tune. I have seen on some FSAE forums that it helps a little bit, but I am not convinced that it's worth the tuning time input. Flex fuel sensors, we don't use that. Overrun fuel cut, so I don't have this off. I just cut timing. I'm sorry, I don't cut anything on overrun. You could if you wanted to, but I don't really see the point. Basically, I don't know. It could go either way. If you really know what you're doing and you talk to some people that have used this before, this is optional. I could go either way on it. It's not super necessary for basically cutting fuel on overrun, but I don't know, you could argue either way. EGO control, right now I'm not correcting because I'm still tuning. The best way that it was explained to me by Mike Bissett is if you make a perfect tune, you never need to adjust with your O2 sensor. So when you are tuning your map, when you're modifying your map, you should not be correcting. Otherwise, you're changing your map while you're changing it, which doesn't make any sense. So you want to have it not adjusting while you're tuning, or else you're just chasing your tail and you're modifying stuff while you're trying to change it. So you can think of it like that. Honestly, we ran comp last year with no correction, and it was close enough. Obviously, we do have an O2 sensor, and it can correct for things like temperature, pressure, all sorts of stuff like that that would not be accounted for and can't be accounted for in a simple fuel map. But if you're close enough, it's not a super huge deal. So this AFR table is basically, this is the AFR that you are aiming for at the certain grid lines. So AFR load is TPS. So this is 0% TPS and 100% TPS. So basically up to 50% at 5,000 RPM, we are completely stoichiometric. You could make this leaner if you wanted to try and save some fuel. Remember that saving fuel means you save weight, although it makes your car run hotter, so you just have to be careful. And basically at max RPM, we're 13.5 all day, just because we don't want things to get too hot. The goal of this is to lean it out as much as possible without losing too much power. The more you lean out, the less fuel you use, but the hotter you run. They say lean is mean, but there's more to it than that. It's not necessarily that simple. There's a lot more stuff to it if you read into it. But basically, I wouldn't change this unless you know what you're doing. But you certainly could at least try to lean it out a little bit. I'm sure I will try to lean it out a little bit to try and save fuel. Remember that saving fuel saves weight, which saves time, but it also gets you a better efficiency score, which is small but not insignificant. But if your car overheats because of that, it's clearly not worth it. There's also safety stuff that you can put out for if your AFR is totally out of whack. I don't really use that, but you certainly could. And this is our main guy, fuel volumetric efficiency table. We are going to get back to this later. Batch fire, so you can batch fire if you want, or sequential fire. Honestly, I wonder which one even makes more power or even wastes more fuel. If you batch fire, you're cooling the valve, and also fuel evaporating off the back of a hot valve is really well atomized, and a shitty spray right next to the valve entrance is not. So I would not be dead set on the fact of sequential always being better. Sequential is better when everything is done right. Don't think that you did everything right. Fuel pressure safety, if your fuel pressure is too high or too low, you can basically start cutting stuff off. If you have a fuel pressure sensor, you can certainly use that. Basically, fuel calculation summary, this is similar to like this real-time display on the basic setting. It basically just kind of collects all the gauges that have to do with fuel. Ignition. So this menu is absolutely critical. Now, theoretically, it should be completely set up and you'll never have to touch it. That does not mean you don't need to understand it. Spark mode. There are many different kinds of spark modes in cars. Remember that this ECU is meant to be put into any car, and there are so many different kinds of spark counting. Basically, what we're doing is we're detecting where the crankshaft is and how fast it is moving. It is spinning. That's what we're doing. So there are many different kinds. Most of them are specific to a brand of car. And that's how hard it is it's already, they did all the hard work for you because it's so difficult. Our car is done basically by hand in an extremely difficult method. Well, not extremely difficult, but not easy to understand at the very least. So we use a toothed wheel. On our camshaft, we have one tooth, and on our crankshaft, we have 12 tooth with one cut off. I believe that's correct. 12 trigger wheel teeth with one missing. Angle degrees before top dead center. Basically, where is the tooth according to when the engine is at a certain number of degrees before top dead center. So you would find the tooth and find top dead center, and you would count the degrees between them. Crank wheel, rising edge, you can read the tooltips on these, but rising edge is basically which side of the tooth do you use. Crank wheel is basically like which thing is the actual thing that you're rotating, because some cars use distributors. Obviously we don't. Cam input, so we do obviously have a cam input. There's different ways to do it. A lot of this stuff is I kind of left either as it was or followed the manual to identify it. Fixed advance, I mean, we use a timing advance table. Obviously, fixed timing is for, you know, I guess really, really old cars that maybe don't have adjustable advanced. Even a distributor car has adjustable advanced with, you know, use the centrifugal force or centripetal force to spread out the little thing and change the timing as you accelerate. Yeah, it'll actually use a prediction. So basically, it's trying to guess where you're going to be. First derivative, meaning rate. So it's going to use your timing increase rate to predict where you're going to be, whether you're accelerating or decelerating. Cranking dwell, so how many milliseconds is the spark firing, or is the coil dwell time happening when you're cranking, as in when you're starting the car. Cranking advance, this should be, I think it actually says, typically between 5 to 10 degrees. This is something that if you're having trouble starting, you could try and mess with. I have personally not found it to be useful, although I have heard that it is useful if you're having trouble starting. So keep that in mind. A lot of this stuff is proprietary, you know, like Toyota Multiplex is probably some complicated shit I don't know about. Dwell time, all that stuff. Spark duration, how long you're sparking, etc., etc., etc. I don't really use any of this stuff, so I don't really fully understand it. Okay, cold advance or dwell battery correction. So I guess at different voltages you can change how long the coil is dwelling. I didn't really touch that at all. It was just set as default. Cold advance. I do have this sort of set at like what it was set before. Basically, if you're really cold, you're not going super aggressive on timing. Basically. Actually, I think this is okay. It says, conversely, some engines may prefer retard during warm-up to preheat the catalytic converter. Okay, so this actually might be completely unnecessary. Anyway, once you're above 100, it's normal, so it doesn't really matter. Matte-based timing retard, we don't use that. Noise filtering. I guess you can filter noise. We do have resistors on the crank position sensor, so this isn't super necessary. Knock sensor, we don't use a knock sensor, but why don't we use a knock sensor? Isn't that a good thing? No. Well, yes, but we don't need it. The reason we don't need it is because we have a restrictor. Therefore, we are not filling the cylinders with enough air to reach a high enough cylinder pressure to require a knock sensor, because our engine does not and will not ever knock ever. Our cylinders simply don't have enough air in them to require it. Cylinder pressure is equivalent to horsepower most of the time. And the reason that we have lower horsepower than a stock CBR is because we're not letting in as much air. If we're not letting as much air, then we don't reach as much high of cylinder pressures. And if we don't reach that high of cylinder pressures, then we don't knock, and we don't need a knock sensor. Once again, spark calculation summary. This is a summary of gauges for everything that has to do with spark. Cranking startup settings. So every time I change this number, it doesn't change anything. Every time I change this number, it doesn't do anything. So I don't actually know what these do. The starter starts at whatever it starts at, and yeah, it's not connected to the ECU, so I'm pretty sure this doesn't change anything. You can also mess with, I guess, some curves and stuff right here if you're really having trouble starting. We haven't, so I haven't ever touched it. Priming pulse. This is basically your pulse width in milliseconds for when you turn the key on but the engine is off. So it'll basically spray fuel at the inside of the valves, or at the back of the valves, in order to basically get some fuel in there before you start. Makes it a little richer for when it's cold, etc., etc. That's why you prime your fuel pump, is for that. Cranking pulse. This is the pulse width in percentage, as in a traditional cranking pulse multiplied by this percentage for when you're starting. So, and it's also at different temperatures, so you need more fuel when it's cold and less fuel when it's hot. I have found that this engine likes to be lean because we have a restrictor, so it needs only a small amount of fuel, and if you have too much fuel in this cranking pulse, then it won't start very well when it's hot. Beware of this. This could cause backfires. I'm sure you'll probably hear the story of the intake exploding. I'm almost certain that this is what caused it. I made it too lean, so beware of that. After start enrichment, basically immediately after the engine is started, it's normal to need additional fuel. I'm literally reading this verbatim. That's exactly what it is. I don't even use this past a normal operating temperature or anything like that, because, like I said sort of earlier, this kind of falls in line with, I don't think this engine really needs additional fuel to start when it's cold, because it already needs less fuel to start at all. Warm-up enrichment, basically you might want a little extra fuel when it's cold outside, just to kind of make it happy. This is basically like a choke. That's how you could think of this. This is a choke. Like on a normal motorcycle, that's what this is. Idle control, we don't use a idle control valve, so that's what this would be for, but we don't use one, we don't need one, etc. Air conditioning idle up, basically if you turn your air conditioning, when your air conditioning, your compressor clicks in and is putting load on the engine, you would want to increase your idle, and this is how you would control that. Which obviously does not apply to us, but just for reference. Idle advanced settings, I don't mess with this. I don't really mess with idle advance. You could maybe make it idle a little smoother if you wanted to, but I've never really found the need. Idle VE settings, we're going to talk about this later. Excel Enrich is pretty important, but not super important. I do think it makes a difference, but I don't think it makes a huge difference. Basically, this will, using the accelerator, as in the gas pedal, when you slam it, you're opening the engine up to air, but the fuel needs a little bit more time to catch up than how fast you're opening the throttle. So by the difference between the time difference between you starting to press the pedal, as in your TPS is at 0, and when you're fully pressed, that time difference, if you take that 100% divided by that time difference, you're going to get what's called TPS dot, or whatever, the change in the rate of change of the TPS. So as you go from 0 to 50, it's going to realize, oh shit, he's pressing that throttle really hard. I'm going to assume that he's going to go all the way to 100, and I'm going to spray in extra fuel to predict that. This, basically what this does is it makes it so that you have faster throttle response. It uses the computer to predict what you're going to do using the rate of change of TPS in order to guess what you're going to do, and it sprays more fuel accordingly, more fuel than it normally would. Basically, it adds a little bit more according to a TPS dot. If you're really lazy on throttle, as in like you're trying to rev it and it's just not happy, you could try and adjust this. Just try it out, test it. It's not going to really hurt anything. So you could. Understanding TPS dot, this is not intuitive, obviously, because we don't really understand that, but it could take some testing and stuff, and that might help you. Okay, yeah, so sets the TPS that is considered wide open throttle based on RPM. So I think this isn't even on, but I guess you could you could just set wide open throttle for different values based on RPM. At low RPMs, partial throttle will flow the same air as full throttle. At maximum RPM, full throttle is required for full airflow. When throttle is at or beyond the new full throttle, it is considered 100% throttle. This has the effect of making a TPS-based accel enrichment more sensitive at low throttle. Oh, okay, I understand. So this is basically like if you guys know what a pedal controller is, that's basically what this is, except a little different. So anyway, boost, we don't, I've never touched this because we don't have boost or VVT, although it would be cool. This is for like dual fuel, which we don't use, and advanced engine. So speed and gear sensor. There's another big window full of stuff. So VSS1 input type, digital, analog. We use digital because we use Hall effect sensors. I suppose you could have different sensors. This is where you would set that. The digital input, so the way that it's set up right now is the data logger, the AIM Evo 5 data logger takes the sensor input from each wheel and then transmit it via CAN bus to the ECU. So this is receiving the VSS, which is vehicle speed sensor. It's recording, it's taking in VSS on the CAN line. You set wheel diameter, which is 444 millimeters, so 0.444 meters. VSS position type, wheel, like, so basically ours is it's on the axle, which is the wheel, but you could also have it on the drive line. That's what most normal cars actually have, is it's in the transmission, and then you would like set other stuff accordingly. Scalar percentage, lag factor, and smoothing factor. I guess this is just to kind of make the data more consistent. So, and then sensor 2. So obviously for traction control, you have two sensors, driven and undriven, and this is where you would differentiate that. This is all, of course, exactly the same. Oh, this is 0.444. Gear detection. So the way that I have it set up now is it calculates the gear on either side of the CAN line. So it calculates it at the ECU and it calculates it at the data logger. I felt like this was simpler because you don't have to transmit what gear you're in on the CAN line, because we have RPM and miles per hour on each side, so, and it has the ability to calculate the gear on each side, so it's not really necessary to transmit it by the CAN line. Shaft speed, this is like if you wanted to, I guess, have input for drive shafts. EGT thermocouple settings, this is where the EGTs are set up. They're not set up right now, but this is where you would set that up. Generic sensor inputs, this is exactly what it sounds like. So we have fuel pressure and oil pressure set up as generic sensor inputs. You either test or you use the documentation to calculate 0 value and 5 volt value. And this lag factor I just kind of set, and then you can use this for like gauges on here and stuff like that to sort of make sure that nothing whack is going on. And if you really wanted to, you could use fuel pressure and oil pressure to make safety things where you shut the engine off, or whatever. If your oil pressure is too low, you can shut the engine off. That is if you trust your oil pressure sensor, which I usually don't. And then fuel pressure sensor, you can do some weird stuff with your fuel pressure sensors. I don't recommend it because it's really complicated and you don't get much benefit, but you can. Acceleration parameters, so this is if you want to transmit data logger, basically G's, right, your accelerometer data through here. I don't actually know what they would use this for, because theoretically you can use this for TC, for traction control, but I don't know how it works. Traction control, this isn't fully set up either, but the general idea is the traction control method I'm using right now is percentage of slip according to the speed sensor. So it takes in the speed sensor of the driven wheels, the rear, which is VSS1, and the undriven wheels, which is the front, and then it compares them. You guys should know how traction control works. If you're spinning the rear, that means that your rear wheel speed sensors are faster than the front, and then it will cut timing accordingly. Or it'll retard timing, it won't cut it actually. And then the slip setting, you can adjust that. You can also set it to a fixed input, but right now I have it adjustable. That's the wrong one. So you can retard it a different amount depending on how much you're slipping. You can also you can cut. If it's really bad, you can just say, screw it, I'm not even gonna retard timing, I'm just gonna cut it. And then there's also like boost and nitrous stuff, which we don't use, although it would be cool if we could. Launch control in 2-step and 3-step if you have it, which we probably won't. This is where you would control that. I don't have it set up right now. I think it's possible to set it up. Yeah, this is where you'd set that up. Speed-based launch control. I believe this is like rolling launch control, or like rolling anti-lag. Sequential shift cut. This is another thing I introduced. So basically the shifter, when you click the shifter, it sends a signal to the ECU, which comes in on digital in out 4 for us. So that's button input. And then it sends out to the solenoid on high current out 3. That's because it directly engages the solenoid. So it's on the high current line. Basically, these parameters right here are when you allow it to happen. So allow it above 1,000, which is all the time, and above TPS 0. This is like the minimum you can set it to. So basically it makes it so that you can shift all the time, which if you think about it sort of makes sense, because if you're stopped, then your TPS is probably 0, but if you're idling, it's above 0, so you can still upshift into second gear if you really wanted to, but you would just downshift into first. Delay before spark cut. You can sort of read the tooltip and get a general idea. So the solenoid is activated immediately. This is important. So the solenoid is activated immediately, and then you wait this amount of time before cutting spark. So because it's a pneumatic solenoid, it pressurizes the air, and it sort of takes a little bit of time to sort of get going. So it starts pressurizing it, waits 100 milliseconds for it to sort of start going, then it cuts timing, and then you shift, and then it cuts the spark for 100 milliseconds, and then it keeps the solenoid powered after the spark is returned. So it pressurizes, shifts, cuts timing, stops cutting timing, and then releases. That's sort of how you can think about it. You can set different delays for each gear. And then you can actually make this shift automatically if you really wanted to. Nitrous, we don't have nitrous. Water injection, God, I wish. High power time enrichment, we don't really need that. Oil pressure, you can make it so the oil pressure will, I guess, like give warnings and stuff per RPM. So basically, if you have low oil pressure, you can make it do stuff. Pit lane limiter, basically a speed limiter. Here we go, programmable on-off outputs. So this is also another important one. I think we have one on here. So this is the water pump, I believe. So digital output 2, this controls the water pump. So when coolant is above 140, the water pump turns on. And when it's below 140, it's not on. That simple. Here's another set of programmable outputs. You can also set generic pulse width modulation outputs. This is probably not super necessary unless you wanted to PWM the fan, which certainly is not a bad idea, because the fan draws a lot of current all at once. So if you put it on a PWM, then you could soft start it. You can also do closed loop is like O2 sensor is closed loop, so it takes feedback and then does action, sees what that does, takes a different action, sees what that changes, takes a different action. So you can kind of think of it like an O2 sensor and EGO correction. 3D tuning maps, exactly what it sounds like. 3D tuning map. Look at how fancy that looks. CAN bus. So these are the CAN bus parameters. You can set all sorts of CAN bus stuff that I don't fully understand. This CAN ID is supposed to be 0, unless you're doing something special, as far as I know. And this on-off is like how I believe this just is like a global on-off. CAN broadcasting. This, I believe, controls broadcast out to the data logger and dash. Real-time data broadcasting. I'm pretty sure this is similar to the other CAN broadcasting, but it's more specific. I don't use this, although it's possible that it may be used in the future to get other specific things. Receiving. This is how I receive data from the data logger. So this I will cover in a separate video on how exactly the CAN system works and what all this stuff means. That will be a completely separate video because it's sort of off topic. CAN VSS, basically it has the VSS coming in, and this is like how it reads it. Honestly, this I believe is wrong, but it still works. This I also believe to be wrong, but it still works. If I change this to 8, it stops working. I don't know why. CAN EGO, we don't use that. You can set clock, IO box. This is buttons. IO box is buttons. Dash broadcasting, we don't use this for that. You can also set check engine lights, which once again we don't use this to connect to the dash. We connect to the dash with the data logger. Output test mode, this is important for testing. So this is where you would test the injectors and spark. This is very useful. When it's connected, you can enable the test mode, and then you can test the coils, test the injectors. Most of this stuff is pretty self-explanatory, and you can basically test it to see if it's working. That's something you would do before you try and turn the engine over. You can also test every IO that you have. So the fuel pump, your PWM outs, your high current, stuff like that. IAC is typically idler control, but we don't have one, so we use it for other stuff. But I believe it's another PWM out. This is more PWM outs, digital frequency, stuff like that. These are basically all IO IOs that you would have. CAN IO is the same. I would be careful of messing with this unless you really know what you're doing, because you can actually break shit if you accidentally give it give low on a high line. You can just fry the really expensive electronics. Yeah, you can test injectors as well, and batch and sequential and stuff like that. I've never used that, but I suppose you could. Engine control, this is like if you for some reason couldn't stop the engine, you can stop it from the ECU side. These are basically special options that I don't really think you need. Digital switch tell 12 volt in pull down, so you can change this to pull up or pull down. If you don't know what that means, don't mess with it. And yeah, long-term trim, we don't use that, but that would be for over time if you can trim your fuel back. And then it has a drive-by-wire thing, which we don't use. Okay, so onto the gauge cluster. I'm not connected right now, but percent duty, this is duty cycle of injectors, pulse width in milliseconds of the injectors. This is your pressure, RPM, obviously, coolant temp, manifold air temp, AFR. This is your target, so on that AFR graph where you're targeting, and this is where you're actually at. Volumetric efficiency, this is basically like what number you're at in your table. Timing in degrees, fuel pressure, oil pressure. I set these ones custom, etc. You can make other gauge clusters and basically set whatever gauge cluster you want. If you need like more info, you can use this one where it gives you like a bunch of different parameters and you can change all sorts of stuff like that. If you want to change what the gauges look like, you just right click and then go to designer mode, and then it'll give you like this mode. There's no control Z in this mode, so just be aware of that. You can click on them, and like this fuel load in TPS goes up to 400, which I don't know why, but it does.
So you can right click on it, dashboard designer and properties dialog, and you can change it to basically like end at 100. And then this is like where it's red and where it's yellow. So you can change that. Go back to the normal one. So now underneath all of these bars that we just went over, we have these ones. These are grayed out. I don't know why. But this is your logger. I use this for like if I think I have a tooth issue on my crank wheel. You can use it for that. You can also use it for other logging stuff. It helps, and you can save logs and stuff like that. This is sort of your kind of main place. Yours will probably look different than mine because I'm on a big monitor, but basically this is your holy grail. This is your fuel map, your VE table, your lambda table, whatever you want to call it. They are all the same name for the exact same thing. Basically, these numbers are all completely arbitrary, and they are simply a number that are relative to one another. When you are running the engine, it will show where you're at this table, and basically the certain TPS and certain rev RPM, you will give the engine a certain amount of fuel. You will give the engine what it wants and what it asks for, and that is what you'll do. There's lean spots, there's fat spots, etc. This idle VE table is a separate table specifically for idle. It's basically zoomed in. It's just a zoomed in version, so you can more tightly tune the idle. And there's also one for warm-up enrichment. So that's basically every button and what it does. I'll go over like more specifically tuning the idle and stuff like that in a later video. I'll go over CAN bus in another separate video, but for now I hope that helped, and yeah, I hope you learned something.